All right. In this lecture, we'll go over the basic rules of integrations. As you see the formulas we have here, x to the n dx will give you one increment, and the exponent is algebraic function x to the n plus 1 over n plus 1. That's the integral of x to the n. If you have a function like 1 over x, its integral will be natural log of x, but make sure that x goes within the absolute value sign. Otherwise, you will have domain issues because 1 over x function has all values of x except 0. When I get my answer, natural log within absolute value of x, I'm getting all x values except 0. Negatives are fine. When you have exponential function like e to the ax, the integral will be e to the x divided by the coefficient of x, which is a. All right, so let me look at example 1. We have x to the 3. We add 1 with it. So that exponent again goes in the denominator. So that gives you x to the 4 over 4, and always add integral constant. Second problem. You have 1 over x to the 3. Make sure that you don't take integral of x to the 3 in the denominator. You check the exponent on x. If you have 1 over x to the 3, that becomes x to the negative 3, right? And then I need to add 1 again with it. So I get x to the negative 3 plus 1 and divide by the same exponent here plus c. And after simplification, you get x to the negative 2 over negative 2. And that's why that negative, we put it outside here. And x to the negative 2, sometimes in some questions, we say don't keep negative exponents. So then x to the negative 2, you can pull back to square in here. All right. And then when you post some answers, sometimes it is good if you're writing with this slash sign here. Make sure that everything you have in the denominator goes under the parenthesis. All right. So this is the integration of power type functions, x to the n type functions. The next example comes with e to the ax type, and identify that a is 27. So as you have seen in the formula, e to the ax, that gives you e to the x over a. So that exactly goes here. A is 27. Next one is any constant if you have no x within it. This is the integral sign, and dx is actually telling you what is your variable of integration. In between, you don't have any x, so the answer will be this constant times x. And integral constant we add. The next example. You have x to the 3 over 5 and cube root of x. First, you look at the exponents. This one has x to the 3 over 5, and that one has 1/3. So we add 1 with the exponent, 3 over 5 plus 1 over 3 over 5 plus 1. Same thing here, 1/3 plus 1, 1/3 plus 1 in the denominator. And after that, you just need to simplify what is 3 over 5 plus 1, and I can show you in the graphing calculator, you can easily do that work. So what you do, you type 3 over 5, so you have 3 divided by 5 plus 1, right? Hit enter, that will give you decimal answer. Then you go to math and ask for fraction. This is option 1, enter. So that gives you back in 8 over 5. So that is exactly right here. And same way you can try with 1/3 plus 1, that will give you 4/3. And when this one goes in the denominator, you put it up with reciprocal form. That makes it 5 over 8 then. And 4/3 makes it 3 over 4, right? And that's your integral. Example number 6. Here I have a single term, but we know the exponent on x will be 9 over this 7. And then again you add 1 and complete your integral. All right. So this is our first 6 examples. Now I'm going to the second part of this. If you have some function again, you see that you have 50x plus 40 squared in here. It could be any exponent. So this one, what we do, not writing any changes on it, consider this one as your x and use the power rule again, add 1 with it. So 2 plus 1 is 3. And then also 3 here. And now look at this is not x, which is 50x plus 4, and then the coefficient of x is 50. You write as 1 over 50, and that's it. And why this one is working, I give an example in here. First, you can use as a formula that if you have a linear function to the n, then that linear function to the n plus 1 over n plus 1 basically, and then the coefficient of x, you write 1 over a. And again, you may ask that why it is working. Go with the substitution method. U is ax plus b that we have taken inside from here. And then take the derivative both sides. Du dx will be left side. The derivative of ax plus b will give you simply a. You know that, right? Multiply both sides by dx. You get du equals a dx. Now, I need to find what is my dx. So that's why I divide both sides by a. We get dx equals 1 over a du. You can write other way. You can write dx on the left side or on the right side. It doesn't matter. And then substitute back everything. Ax plus b is written as u to the n. And then we have 1 over a du. 1 over a is constant. Leave it outside. And then again is u to the n. Isn't it similar like x to the n? So we just add 1. And then after that, substitute back what is u, which is ax plus b. And that exactly gives you the same answer we just said in the formula. All right? And same thing happens for exponential also. Now you can see two more examples in here. E to the 3x plus 4 will give you e to the 3x plus 4. And the coefficient of x is 3. That you write 1/3, right? And that's all in here.